now that we know that there's actually DNA in the bones of the cima de los huesos hominins, we can actually start to treat that cave like a crime scene and do the same things that forensic investigators would do.
Deep within a Siberian cave, scientists drilled into a 40,000-year-old finger bone, no bigger than a pebble. They extracted a few fragile strands of DNA and fed the data into a sequencing machine. What came back wasn't just the story of one individual. It was a ghost from our past. We've always been told the story of human evolution is a straight line, with us at the top. But the thing nobody tells you is, that's a lie. This ancient DNA revealed a web of connections, secret migrations, and a shocking truth about who we really are. Before the code. They're very close to us. They're almost us, but they're not quite us. For more than a century, the image of Neanderthals has captured human imagination. Many people are crazy about the idea of them. These were real people, incredibly close cousins of ours who walked the same paths and faced the same harsh winters as our ancestors. Their bones have been found across a huge stretch of land, from the forests of Spain to the frozen plains of Siberia, a range of thousands of miles. These remains told a story of strong bodies, wide noses that helped them breathe icy air, and skulls with heavy brows that gave them a different look, yet still unmistakably human. You see, archaeologists digging in caves and riverbeds discovered their stone tools lying beside their skeletons. They found hearths filled with ash, proving these people controlled fire. They uncovered piles of animal bones cracked open for marrow, proof that Neanderthals knew how to squeeze every bit of energy from a hunt. To put it mildly, these signs revealed a truth that stunned the world at the time. Neanderthals were not just savages, they were skilled hunters, expert tool builders, and masters of survival in one of the hardest times the Earth had ever seen, the Ice Age. But their story was not only about survival, it was also a massive mystery. One question hung in the air: where did they come from? At first, scientists thought the answer was simple. The earliest Neanderthal fossils were found in Europe, so for generations, textbooks taught that they were a European species. But as more bones were unearthed in new places, the neat story of a purely European origin began to fall apart. What many overlooked was the growing evidence from the East. In the Middle East, fossils appeared that seemed to mix Neanderthal features with those of early Homo sapiens. Then, bones were discovered in Central Asia, far beyond Europe's borders. The breakthrough came with a powerful new tool, the study of ancient DNA. For most of history, scientists only had bones and tools. But in the late 20th and early 21st centuries, technology advanced enough to pull tiny fragments of DNA out of ancient teeth and bones. Hopes were high that this new science would finally solve the riddle. The first results confirmed that Neanderthals and modern humans were not distant relatives. We were kin. Both of us traced back to the same ancestor who lived between 500,000 and 600,000 years ago. This ancestor gave rise to different branches of the human family tree. One branch would become us, Homo sapiens, and another would become the Neanderthals. One of the most important sites in this discovery was a cave in northern Spain called Cima de los Huesos, the Pit of Bones. In its deep chambers lay the remains of more than 24 individuals, preserved for around 430,000 years. Their skeletons showed features that clearly pointed toward Neanderthals. But when DNA was extracted, the story got weird. The nuclear DNA, inherited from both parents, showed they were indeed early Neanderthals. But the mitochondrial DNA, passed down only from mothers, was closer to another ancient group, the Denisovans, who lived thousands of miles away in Siberia. This was a what the fuck moment for genetics. How could this be? The answer pointed to something far more complex. The idea of a simple split was gone. The thing nobody tells you is that this wasn't a clean break. The family tree was less like a straight line and more like a braided river, with streams separating, joining, and weaving back together. But this was just the first clue that our family history was far stranger than we knew. The Siberian surprise. When scientists finally sequenced the first complete Neanderthal genomes, the results changed everything. For a long time, People had imagined a simple picture of one species spread wide. But the DNA told a completely different story. Neanderthals were not one uniform population. You see, they were divided into separate groups, living far apart, yet still connected in surprising ways. Their genetic code revealed a history filled with both isolation and reunion, like a family that drifted apart and came back together again. The DNA showed two main branches. In the West, populations lived in Europe. In the East, thousands of miles away, another group lived in the rugged lands of Siberia. Though separated by enormous distances, both groups carried the clear marks of being Neanderthal. However, their DNA showed they had been apart for tens of thousands of years, long enough to develop separate genetic identities. But the story didn't end there. The most shocking fact is that these groups were not fully cut off. From time to time, they reconnected. Waves of migration carried one group into the territory of the other, replacing local populations or mixing with them. The reasons for this are written in the changing climate. As glaciers grew and melted, new migration corridors opened and closed. Herds of animals moved, and Neanderthal bands followed them, carrying their bloodlines across continents. This means Neanderthals were never a fixed people. They were flexible and mobile. A striking example came from a Siberian cave called Chagirskaya. When scientists studied the DNA of a Neanderthal found there, they were floored. Even though this individual lived deep in the East, their genetic code was much closer to European Neanderthals. This proved that a massive migration had occurred, with Neanderthals traveling thousands of miles across harsh landscapes. What many overlooked is just how monumental this journey was. It's like walking from New York to Alaska. So how did they stay connected? The answer lies in the natural highways of the Ice Age. When glaciers pulled back, they left wide-open valleys and grasslands teeming with mammoths, bison, and deer. Neanderthal hunters followed these herds, and over generations, small bands could cover vast distances. For long stretches, groups lived apart, separated by ice sheets or mountains. Their DNA drifted, but then, when climates changed, the barriers melted and people moved. In those moments, Neanderthals met again, sharing tools, food, and bloodlines. Each encounter blurred the differences, creating a patchwork of connections stretching for thousands of miles. The idea of a simple family tree no longer works. Instead, their story is a web that spread from the Atlantic coast of Europe to the far side of Asia. And you can see this everywhere in their genes. Their world was not simple or static. It was dynamic, full of movement, meetings, and replacements. But they weren't the only ancient humans leaving their mark on the world. More than a meeting. Into this already tangled story, another species stepped in, the Denisovans. For years, Denisovans were completely unknown to science. They left almost no bones, no clear tools, no art. They were ghosts. Everything changed when a few fragments of bone and teeth were found in a cave in Siberia, called Denisova. From those tiny scraps, DNA revealed the presence of an entire new branch of humanity. The thing nobody tells you is that they were incredibly close to Neanderthals, but genetically distinct, a third kind of human, shaped by their own journey across Asia. The most surprising part was how closely their story was tied to the Neanderthals. Deep in the Altai Mountains and across Siberia, the two groups lived near one another. Sometimes they may have shared the same caves, separated by only a few generations, and they did more than live side by side. The DNA proves they interbred. Hybrids were born carrying the signatures of both peoples. Denisovans inherited large chunks of Neanderthal DNA, and some of those genes proved valuable, helping with immunity and adaptation to cold. But the exchange was not one-sided. Neanderthals also carried pieces of Denisovan DNA. These meetings were not single freak events. They happened again and again across different times and places. Rather than three separate boxes, Neanderthal, Denisovan, Homo sapiens, the reality was a messy, tangled web of connections. Each meeting blurred the lines, reminding us that these categories were never as fixed as we once imagined. What many overlooked is that this genetic sharing was a key survival strategy, and these crossings left deep marks that are still with us. Even today, modern humans in parts of Asia and Oceania carry Denisovan DNA. In Tibet, for example, a Denisovan gene helps people live at high altitudes where oxygen is thin. This is a direct legacy of encounters that happened tens of thousands of years ago. To put it mildly, their story didn't fade away. It lives on inside billions of people. The Neanderthal identity was not forged in one place. It was built through endless crossings, through the highways of ice and stone that linked one land to another. The Denisovans were one of the most important threads in that web, binding East and West together. Their story was a complex dance of survival, migration, and connection across a massive continent. But a new player was about to enter the game, and their arrival would change everything. Not an ending. For hundreds of thousands of years, Neanderthals held their ground. They had survived it all. Yet one encounter would change their story forever. It wasn't with the cold or with hunger. It was with us. Modern humans, Homo sapiens, had emerged in Africa and began to spread outward. The true turning point arrived around 47 to 50,000 years ago, when waves of modern humans began to pour into Eurasia in numbers far greater than before. They moved into Europe and Asia, and with them came a force strong enough to shift the balance forever. Genetic evidence tells us that during this period, interbreeding between Neanderthals and modern humans became common. The most shocking fact is that every person alive today with ancestry outside of Africa carries between 1 and 2% of Neanderthal DNA. This inheritance was powerful. Some Neanderthal genes strengthened our immune systems. Other fragments influenced our skin and hair, helping our African ancestors adapt to the colder, darker climates of the north. But not every gift was a blessing. Some Neanderthal variants increased risks for certain modern diseases. For the Neanderthals, however, our arrival brought a challenge they couldn't overcome. Our larger, more socially connected groups gave us a survival edge. We formed wider networks, sharing knowledge and resources over long distances, allowing us to adapt more quickly. By the final chapters of their history, their strength was waning. The Altai Neanderthal genome reveals the depth of their struggle. Within her DNA, scientists found long stretches of identical sequences, a clear sign of inbreeding. Their populations had become small and isolated. The environment also pressed hard against them, with shifting climates draining their strength. Into this fragile balance came Homo sapiens. By about 40,000 years ago, the Neanderthals disappeared as a separate people. To many, this looks like extinction. But the DNA tells a different story. Even as their distinct populations vanished, their genes flowed into ours. They survive in the way our immune systems fight disease, in the shades of our hair and skin, in the very structure of our biology. So, are we missing a key detail here? For people watching this, the story of the Neanderthals has always been a simple one, a primitive species that just couldn't compete and was wiped out. But the thing is, their disappearance wasn't a clean break, but a transformation. It wasn't an overnight event. They became part of us. Recent genetic discoveries have completely flipped the script. Scientists found that Neanderthals didn't just vanish, they interbred with our direct ancestors. Their DNA was absorbed into the human gene pool. This wasn't a conquest, it was a merger. Their legacy is not written only in fossils or ancient stone tools, but in our living bodies. Every time a person with non-African heritage looks in the mirror, they carry faint but powerful echoes of Neanderthals within them. That DNA influences everything from our immune systems to how our skin tans and even our susceptibility to certain allergies. The real mystery, then, is not why they vanished. The real mystery is how much of them still walks among us, shaping who we are in ways we're only just beginning to understand. Their story was not about defeat, but about a connection so profound it reshaped our own species. We are not looking at a long-lost separate species of strangers. When we look at the evidence, we are looking at a forgotten part of ourselves. So, if Neanderthals are part of us, did we truly outcompete them, or did we just absorb them into our story? Let us know your thoughts below. Like and subscribe for more.